Okay, so we're going to talk about, this is binomial expansion. This is like the general terms for what they'll call it. So we have a binomial, we'll call it A, and the other term in there is B, and it's to the power of some exponent, okay? We've worked on a formula to find terms, but we're actually going to work on like the general expansion. And what that means is instead of having a simplified form, which is what this is almost like a factored form of something, we're going to do the full expansion of it. So what would that look like? And it turns out you can follow this little formula here using combinations. So whatever my power is, my combination is that value to 0. Okay. Now what's interesting about that, and I'm going to rewrite this just so the colors match up a little better. We have n to the 0, and it turns out that ends up just being 1. If you take a look at Pascal's triangle, it's a simple one. Everything on the outside is always 1. We then take each term. So we'll call this first term. A is the first term. So I'll put it like that. And we have to put it to a power. It turns out we put it to the power of n, whatever a is. And a could have exponents to itself also. So what you're going to notice is it's actually going to match this value here, the very first one. And then the second one we use is the second term, b, and it doesn't matter what b is. It could be lots of things. We're going to put that to 0, which happens to match this part of the combination, okay? So the very first one ends up being whatever the top term in the combination is, that's what this one's going to be, and whatever the bottom term in that combination, that one's going to be. So that would be the first term together, which is a heck of a lot of information for calculating just one term. And then the next term, we don't know what n is, but it's going to be n1. So essentially we're counting up. We're eventually going to get to a place where it's going to be n to the n. We just don't know what it is in this case. Our a value is going to be a little more unique. It's no longer going to be to the power of n, but instead it is to the power of n minus 1. And if you notice, thank you, Trixie, n minus 1, n is here, and we're actually just subtracting whatever, oops, I don't want that one. We're actually just subtracting whatever this bottom term is in the combination. So I could have actually done it in the first one. We don't usually write it that way, but I could say n minus 0, which is completely fine. That's a 0 also, right? And then our b term, I'm going to go get her in a second, would be whatever that term is. We're going to put it to that power, okay? So let's say I make up a question. I'm going to make up a question that looks like this. We have some binomial. We'll say it is 3x squared minus 5, and I'm going to put x to the power of 2 like this, okay? And we'll put the expansion at 3. So just so it's not super large, and we can get a general idea of it. Actually, I lied. Let's make it to 5. I know it's a bit larger, but then we can see the pattern a little better that way, okay? So let's say we've been given this binomial, and they said, can you expand this? One way we can simplify this, which you and I talked about, is actually not making this a fraction. Let's actually make it an exponent, but it'll just be a negative value. So I could say it's also equal to 3x squared minus 5x to the power of negative 2. And that might be a little more tractable, a little easier for it to understand, because fractions can get a bit confusing sometimes. We're going to label our stuff. This will be my a value, so that's everything in there is the a value. And this will be my b value, which I know it looks funny to keep that negative in there, but that negative is actually going to be important. It's actually part of it, okay? This will be my b value. And then, did I give a color to n? I don't think I had. This will be my n value. That doesn't look like an n. There we go. Will be the number 5. So when I go to write this in my expanded form, all right, we're going to start with my combination. My n term. What is my n term? Well, it happens to be 5. So we're going to say 5 to the power of 0. Or sorry, not to the power of 5, choose 0. Our first term is a, so let's write it in. It is 3x squared, so that's everything in there. And that's going to be to the 5 minus 0. I'm going to write it that way, even though you could have just written as 5. It's the n value. And then on the next one, we have a b term. That b term is everything in there, which happens to be negative 5 to the x minus 2. And then its exponent is actually just whatever the bottom of this is, which happens to be 0, okay? So before I even get to my next one, because it's going to take off, I'm going to do a little evaluation of this and see how it simplifies. 5, choose 0 happens to be 1, Okay, this becomes to the power of 5, so I actually got to multiply it in. So it's actually going to look like this: 3 to the power of 5, and then x to the power of 2 times 5. Okay, that's just an exponent law, power of a power we've used. This one here, exact same idea, negative 5 to the power of 0, right? Because technically there's a little 1 here. I didn't write the 1s in for those coefficients, but it's like 0 times 1 becomes 0. And this one here becomes x to the power of negative 2 times 0, which is going to have quite an impact on this. When we go to simplify that, 1 times anything is going to be 1. 3 to the power of 5, I don't know what that is off my head. Let's get a little calculator out here. Let's go. 3 power 5. There we go, 243. Okay, so this is going to become 243. My x, I'm just going to multiply those two terms, so x to the power of 10. Okay, and let's see what the second piece is. Well, negative 5 to the power of 0 is going to be 1. And then x, negative 2 times 0, well, that's going to give me x to the power of 0, which is also 1. So it's like multiplying by 1. And I've done this in a lot of steps. You might be able to do this in one whole step. This ends up being just 243 x to the power of 10. That's just the first term. Okay, we have a whole bunch of other terms we can deal with. So I'll repeat it again for 2 more of them, and then we'll kind of have the idea to it. The second term here would be 5, choose 1. Our a value is still 3x squared. This time we go 5 minus 1, and our b value, which is negative 5x negative 2, is to the power of 1. Okay, we're going to apply that again. 5 choose 1 happens to be the value of 5. This will end up being just 4 in this case, so we'll get 3 to the power of 4, x2 times 4. This one here will get negative 5 to the 1, and then x negative 2 times 1. I'll carry out this operation here. 3 to the power of 4, that's going to be 8, I think that's 81. So we're going 5 times 81. 2 times 4 will give us 8, so we're x to the power of 8. Negative 5 to the power of 1 is still negative 5. Negative 2 times 1 is still x to the negative 2. Okay. I can turn this into a fraction, so I'm going to have to do a little extra work here just because we can reduce these values here. I'm going to make this part here is going to go under. It's going to go underneath. So we end up with 5, it's a funny looking 5, times 81 x to the power of 8. This negative 5 still stays on top, okay? Because its exponent is technically a positive value. So it'll be negative 5. And then finally below we get x to the power of 2. The reason we did this is just so we can simplify that variable's exponent. It'll make it a bit simpler to work with. I'm going to have to figure out what this coefficient will be, which will be 25 times 81. So I'll solve that in a moment. But we can reduce our variable. When we get this scenario, we get a unique situation where if you have, that's not the letter I want, x to the power of a over x to the power of b, so the bases are the same, we can rewrite that as x to the power of a minus b. In this case, that's 8 minus 2. I can just write that as x6. And because it's positive, it would be on the numerator, that piece. So I no longer need that bottom part of the fraction. It's gone. Hey Google, what's 25 times 81?
The answer is 2025.
All right, 2025.
But that's negative, right?
100%. That is negative because of that negative value. So we change this little operator. And really, this is a terribly written part, but this is the first term. This is the second term. I should be putting them all together, which I will. If I make a good version of this, I might go, okay, here's my first term, 2, 4, 3, x to the power of 10. And it turns out my second term is subtract 2025 x to the power of 6. Look at that. That's a big change, which probably means we're going to get another big change by the time we get to the next one. So if a question was asking me for this specific piece and I needed to find the coefficient, I might start a little farther down the line, knowing that 1's a little too high. I might jump to the third or fourth term and then work back or work forward depending on where that lands. Does that idea make sense? Yeah.